All right, so we are Delfin and we are revolutionizing energy worker efficiency, doing text analytics for unstructured data. So to get started, I need to make a differentiation between data that is structured and data that is unstructured. When I say, hey, we're doing things for unstructured data, like what the heck is that and why does that matter? So structured data is what data scientists call data that has a home. So if I ask some people if they've been to Mexico, because I ask multiple people the same question, I can organize their answers in relation to that question. And I can also ask more questions and use the same organization template. And that really helps software. So you can teach software that if it wants to know something about Eduardo, it can just look in column B. And if it wants to know something about spinach, it can look in row 3. So B3 is going to be Eduardo spinach. It becomes very easy then to start extracting insights from this, making predictions, categorizing things, perhaps using machine learning or something like that. So structured data is very friendly to the classical, traditional software. Unstructured data, by contrast, is the information that either does not have predefined labels or is not organized in a predefined template. So it's typically text heavy, but it does contain some numbers. And it's typically generated by people, not by sensors or computers. In our industry, unstructured data exists in the form of digital unstructured textual files. We call those DUT files. They're the most common sources of unstructured data in the industry. And they're full of irregularities and ambiguities that make it really difficult for traditional programs to navigate as compared to structured data. This body of text here is a good example. And in fact, this whole PowerPoint presentation is a good example. Let's say that later on you remembered that I taught some kind of acronym and you wanted to go find that acronym. Like, what the heck was that acronym? Something about textual something. Maybe it was written files, and you're going to have to open this presentation after you find the presentation and then scroll around until you find, oh yeah, DUT files, that's the one. So that's kind of like the challenge to unstructured data. And it's hard for machines to just know where to look because you haven't told them where to look. So we've asked people across the industry, and we have a lot more data now. We're going to publish this soon in a blog or maybe in a report through one of these professional societies. So these are old slides, but the trend still holds. How often in your job do you need to reference unstructured data in order to make an informed decision? And what you notice here is that nobody ever says seldom or rarely. It's always like something else. So, okay, people are having to do this a lot. We ask them, how satisfied are you with the ability of your current resources to give you instant and accurate answers? And like the last slide, there's nothing over here. Nobody is satisfied. So everybody has this problem and nobody is satisfied. This is across the industry, okay? And it's not just that it's already bad, it's actually exacerbating. So what's changing that makes this more of an important issue? Well, first, says Forbes, from 2015 through the end of 2020, the practitioners in oil and gas that existed in 2015, half of them will have retired by the end of 2020. And they leave behind this enormous expertise gap when they go. And every 2 who leave the industry, only 1 person joins. So these new people who are coming in have to fill the shoes of the old people who are leaving. And the new people who are coming in have access to a bunch of retained knowledge that's left behind in the form of unstructured textual files from the people who are leaving. But they're not as efficient making decisions because they have to reference those files to make sure that their decisions are fully informed. So you're stuck either making uninformed decisions, which are dangerous, very risky, or making slower decisions that are equally as informed. So that pain is something that organizations are feeling across the board in oil and gas. In addition, and this is something that's perhaps subjective, but I'm mostly getting this information from management consulting firms, and it fits with my experience in the industry. Oil and gas is a cyclical business, right? That's why I drew this circle. We have boom times and we have bust times, and we kind of go through, maybe the pace is accelerating, or you ask people and they say different things. But typically in the boom times, if people are all profitable, they're kind of like chill, like maybe they're a bit more lazy. And that's why there hasn't been such a big focus on efficiency. And that's why a lot of these new techniques in data science are only just now kind of hitting oil and gas, where in more competitive industries, traditionally that are always in like harder times where things are more competitive. Um, those types um, of data science have already proliferated and created a lot of impact. So maybe it's harder to like have the excitement and interest to implement some of this stuff when you're in a boom time. And then when you're in like a bust time, when times are hard, traditionally what oil and gas does is it fires a lot of people and just kind of bunkers down and doesn't really take initiatives by investing in new things to drive efficiency. But right now we're in this interesting like interim that seems sustainable where we're at break-even pricing. So the price of hydrocarbons is low, which means that the profit margins are smaller. So that's what I mean by break even. And when that happens, you have less free cash flow. When you have less free cash flow, you give less of it back in the form of dividends to your investors, which makes them unhappy. And that drives down the value of your stock. Once your stock price goes down, then you're at risk of being purchased or having a lot of other challenges, perhaps going out of business, that sort of thing. So to prevent that from happening at this break-even pricing, what do you do? Well, you focus on efficiency, operational efficiency. And if you're more efficient, then you make more profit for the same amount of like effort. And so now suddenly oil and gas is very interested in data science and other kinds of software that traditionally haven't gotten much attention in this industry, despite their advantages in other industries that they've already created. So how is oil and gas now trying to solve these problems? Well, I've seen a few different things, and I've also learned just through like studying the market some of these things. And there's two main things. Like one is data organization projects, and this is typically what you hire management consulting firms to come in and do for you. And they will like hang out, charge you a bunch of money, and rename your files. So all those digital unstructured textual files, the DUT files, they'll help you figure out like, here's a more intuitive folder hierarchy on your shared drive. And here's how you should go about naming your files so that they have like a common, naming strategy. And that'll supposedly make it more intuitive to go through and click and find what you're looking for, and your data won't be so siloed and hard to access. And you won't have all these problems that I highlighted in the previous slides. The challenge with this solution here is first, it takes a long time to set up. So one of the processes that I saw when I was still working for a big oil company was that we hired this consulting firm, and suddenly a bunch of subject matter experts are full-time having to like rename their files and organize them into new folder hierarchies. And they have so many files that it's just like a nightmare. It's super exhausting. And it's really like kind of tortuous, as a process. So after a certain amount of time, it was more than 100 hours of subject matter expert time. This entire process was just abandoned. But because it was never finished, it's kind of useless, You never get to like click through and know that when you finally like click into the right folder, you'll find what you're looking for. It's kind of hit or miss. It might be in there, it might not be in there. And even if it did work, the best case scenario is that you're exploring folders. You're like clicking through folders to find information. And when you do finally find information, if it did work, you'd get one result at a time. So you're only finding like one relevant file rather than like all the relevant files to whatever your question was, whatever your concern was. And it's biased in the organization. So despite what management consulting firms might try to do to get rid of this problem, it's always going to be biased. Like somebody might say, well, I think this document belongs in this folder because it has to do with this topic, but it sort of overlaps with another topic. So maybe should it belong in another folder? Should you make a copy of it and like double your storage? That's expensive. Do you organize it by dates, by author, by topic? It's really biased, right? So this is very obsolete. This is the best there was in like the 90s. You shouldn't be doing this anymore. So a lot of organizations have switched to using off-the-shelf enterprise search. And enterprise search has its own problems. First of all, if I ask a question like, why is my downhole pump failing? I've got a downhole pump here, but it's not working. The traditional enterprise search can't understand that question. It doesn't understand the intent of the question, the complexity in that question. I have an effect, and I'm looking for the cause of that effect. My downhole pump is acting up, and I want to know why. But instead, I'm just going to get like keyword search results, and it's giving me files, not specific passages that matter within those results. So I'm just getting back like, here's a whole bunch of files that contain the word downhole pump and maybe contain the word fill. And there might be like thousands of documents that have those things in common. So I'm not really like narrowing down my search or like figuring out what I want to. And if I use the wrong keyword with otherwise the right topic, like my DUT file example, I can't remember the name of that freaking thing. Do I call it like a subsurface pump or a downhole pump? You want it to understand either or, right? So there's a problem with keywords there, and it has no empathy, third and finally here. So when I said my downhole pump, typically it doesn't know who I am or which downhole pumps are affiliated with me. So it doesn't give me back like the right kind of answer. So across the industry, there's a 6% satisfaction rate here. That's no good. Natural language processing is here to help. Natural language processing is basically natural language. So, and then the processing part. So natural language means it's how humans communicate with each other. So I've been speaking this whole time in natural language, and what I've written down on these slides is natural language, as opposed to whatever language we use to communicate with a computer. So the processing part means it's analyzed by a machine. So we're using a machine, a computer, to analyze text that was meant for humans. So that's NLP for our industry. It's unstructured data mining. Unstructured data, you remember that. And we're mining that using, programmatically using software. That's NLP. So here's how we want NLP to work. It's the code, it's the software, and it takes in information in the form of DUT files from an oil company, from an energy company, and it gives back, either or a tool that lets you like type and talk. So you like ask a question, or you type in, like into a search bar. And whether it's listening to you, there's a lot of good, off the shelf kind of like open source stuff that you can just get for that. That's the less important part. The more important part is it's processing your text on the back end after interpreting what you write and then coming back with answers. So you ask a question and you get like instant accurate answers from across your firm that are exhaustive. And then that helps you ask the next question and follow up. And you go through your work a lot faster that way. That has the potential to be exhaustive and instant with each search. That's the potential. So that's pretty exciting. That's a worthwhile goal to pursue. Why is it so worthwhile? Well, right now, the oil and gas industry, energy in general, is reporting that it's spending 80% of practitioner time just looking for its own data. So that means it's only 20% efficient. If you have some expertise and you want to apply that to resolve an issue or make some money for your company, well, too bad. Instead, you have to spend like 80% of your time looking for the information so that you can then apply your expertise and get stuff done. So if that all went away and we got to 100% efficiency, that would be a 5x boost. Just think about what's the total salary in the oil and gas industry. And for the same salary, what if you got 5x boost? What would that be worth? That's huge, right? But it's more than that. It's not just efficiency. There's currently a lot of lost opportunities because people are like looking through files and they only find like part of what's relevant. So they're not like connecting all the dots and thinking creatively the way that they would if they had more time and if they had all the data at their fingertips. There's also all these redundant work efforts that happen. I can't tell you the number of times when I was in the industry directly and when I did consulting projects for oil and gas companies in the industry after I kind of was on the outside looking in, how many times I saw this. Like somebody does this huge project for like weeks and then realizes that someone else has already done that work and they didn't need to reinvent the wheel there. You can get rid of that. If you just search and find it, then you know that somebody did it. But it's not just about like making more money and saving money. It's also about doing things more safely and HSE, so for the environment as well. If I have instantly whatever I need to do and whatever the protocol is at my fingertips whenever I want it, I'm way less likely to make a mistake and do something the wrong way. And there's a lot of complicated scenarios here, and I can't memorize all that information, regardless of how many courses I take. So now I can take fewer courses and be just as safety informed, or perhaps makes a lot of sense to be a lot more safety informed because whenever I'm in a situation, I just ask a question and get back the right answer from my company's documentation. So what we're talking about overall here is better decisions faster. Pretty obvious that this is important to focus on. What's the exact ROI? Well, that depends on the use case. But if the technology exists, you got to be kind of a troglodyte not to like explore it, right? And the technology has a lot of precedence in other industries. This is like how, Google and Facebook and Amazon and Twitter and all these companies that are like making big waves in big software. This is like how they like run their stuff. There's a lot of natural language processing that is burgeoning and it's really kicking butt across multiple industries. And oil and gas is just now starting to scratch the surface there. Exciting times, often sometimes frustrating uh, as well. So there's challenges to this. And I talk about it being frustrating. A lot of that frustration on my part comes from unawareness of these challenges. And as a result of that, investment in solutions that are actually not going to work. So what's the first challenge? The first challenge is that this is not a realistic scenario. You can't build code that's going to take in all of an entire organization's documents, let alone an entire industry's documents, let alone like everybody in every industry's documents, and spit this out and have this just work for you. That just is impossible. That's the state of the art. Even pushing the envelope of the state of the art in natural language processing is just not there. So instead, what you have here is like a huge amount of different types of documents for each part of the company across the whole industry. And when I say for each part of the company, you can split it out even more for each use case, for each type of use case. Like somebody in drilling cares about HSE stuff. They also care about drill bit stuff. They also care about daily drilling reports, KPI code assignment retroactively, so then they can make better predictions. The next time they drill. Those are all different use cases just for drilling, and that's just one part of the whole company here. So if you try to feed all that stuff into one system, the technology is not there. It's going to fail. It's going to be the lowest common denominator across all those things, which is going to suck. And that's exactly what you see. Like there are these like big companies out there that are offering sort of consulting model on this stuff. And they do this for every industry. They're like, we are, able to help any company in any industry with their natural language processing needs. Well, what they start off with is some blank slate that then needs to be trained for that industry, for that company, for that team, for that use case. And that takes forever. And who does the training? Well, the people who have the expertise that's inside the company. That's not okay. That's not going to work. Likewise, there are all these software companies out there, sort of vaporware, that'll say like, hey, we figured this out and we can do this for oil and gas. But they don't have like the ability to like answer anybody's question about the company's data. They're having to bring the answers with them from the outside. And those answers aren't helping the company resolve their issues. The company needs to find their own data, or if they need to find, if it's data from outside the company, it's relevant to their particular issue, So this model is just not going to work, okay? And what works instead is starting with a particular organization, team, use case, and then spinning up a tool from that. And when I say spinning up, you need software that enables this process to be extremely accelerated. Why? Because even though this overcomes the lowest common denominator problem, it still has another problem with it, which is a time problem. So this can take a really long time if you don't have the right expertise. But you can speed it up if you do have the right expertise. And what do I mean by the right expertise? I don't just mean subject matter expertise. I predominantly mean natural language processing, text analytics, software expertise. Why is that? Well, because these people are really, really hard to find. Like every few months, there's a gigantic a shift in NLP. It's just like a really burgeoning part of data science right now. And that's exciting. All sorts of new things are possible. But if you're not already in that game, it's really hard to catch up because it's cumulative knowledge. The new things require you to understand the things that came before too. So there are ways to scratch the surface and create value in NLP for people who are kind of lightweight and new to it. But if you really want to like crush it in NLP, you got to find and recruit and work with people who really know that space very deeply. And those people are really hard to find. And typically they don't want to go work for companies that are in traditional industrial settings where there's consensus driven decision making and you got to have all your ducks in a row before you try things. They want to work in like software where things are very agile and what they're doing is more core to business. So these people are really hard to get. These people are also essential, and having a company that represents the software people as well as the background in oil and gas is also important. But there are a lot of retiring and retired subject matter experts who think this kind of stuff is fun and don't mind helping out a company like this. This is the really hard part, okay? And if you really want this to work across the industry and make something that's scalable, what you need is to go like this. You need to like talk to a company, talk to the team, figure out their challenges with unstructured data, and then resolve those challenges with a curated tool. So you need software that can create the curated tool in each instance. And that software needs to be informed enough with the natural language processing stuff that it's like really, really fast to spin up. Okay. So before I go into talking about that solution, let me just do two quick, more in-depth use cases. And when I say quick and more in-depth, that's not meant to be an oxymoron. I just mean as compared to the use cases that I've kind of alluded to in the past, they'll be more in-depth, but I'm not going to spend a huge amount of time on them. So when I was a reservoir engineer, I spent some time doing these stage out meetings, and these would happen twice a week. I'd get with completions engineers, the geologists, and the geoscientists, the geophysicists, and we'd sit around the table and we would have drilled multiple wells since the last meeting. We had several rigs going. And when we'd run our tools through the wells, we'd come back with these logs, and we'd have to look through the logs and decide where are we going to place the perfs and where are we going to set the different stages inside of the wells to optimize our production. And that's a function of geology. It's also a function of the rig, you know, and it should be a function of what we've done in the past. And so my job was to take all the notes and compile everything and then make sure the completions team did what the notes said and track that down. But inevitably, like, you know, because I was in this company for, you know, or in that role in the company for a couple years, and we did this multiple times a week, I had a huge number of these files, you know, and somebody would then ask me in the next meeting, hey, have we been in this situation before where we had this kind of geology, you know, more or less, and what do we do and what happened and how did it work last time? Maybe we can learn from that, right? And I had in mind that, you know, gosh, what I really ought to do so I can answer that question more timely rather than wait weeks trying to like go research that answer. We didn't have weeks, you know. I thought maybe I could just organize it into this spreadsheet here, something like this. And this is, you know, really dumbed down version just for an example. But, you know, I thought maybe if I organized all the data well enough, I could look at what wells seemed to outperform the average and then what was special about those wells, or maybe those stages or those individual perfs. You know, we're putting tracers and figuring things out here. So we got to be able to learn this stuff, right? And then maybe, you know, conversely, we can also learn, like, for a well that's not performing as well as average, why is that? And what can we learn across all this stuff so that we start to make better decisions when we're doing these stage outs? And what I found was that just take like one cell in the spreadsheet. It's, you know, supposed to be a nice tabulated and structured data sheet, and it really looks more like this, you know. And so very quickly, my entire spreadsheet started to look like each one of those reports that I was already writing. And I realized I can't boil this down, you know. There's some unstructured data that just needs to be unstructured. And it's not just that it's complex, like interdependent and complicated, like really nuanced. It's also like it's dynamic, it's changing, you know. I have to go back in and change things later. So this makes it really, really hard to like use ordinary machine learning or ordinary data analytics on this stuff to start figuring out what to do in what kind of situation. You need text analytics. We're spending a huge amount of time trying to find whether we've done something in the past and how we did it and what we should learn from it. And what we would typically do is, rather than spend all that time doing it, because of the time pressure, we would just make an underinformed decision and reinvent the wheel and decide like, well, let's just put the perf here. That makes sense from people's expertise and their gut feeling, you know, and let's like put something in some place because of that is not like the best way to do it, right? We would realize then when I looked back through that we had done it a different way last time. And, you know, it worked better last time than it did the second time. And I'd have to write a report about that. That should be like a real time learning process, right? You want that to happen like on the fly so that you're fully informed when you're making a decision and not be like somebody's job for half a year to learn like one little like improvement on how you should be doing your stage outs. Another quick example. So let's say that you're considering bidding on this area. There's a lot of wells already drilled here. There's a company that's done that drilling. And maybe you're gonna like buy that company, maybe you're gonna like lease the land, maybe you're gonna buy the land, but whatever you're thinking of like developing in this area, you're gonna have to place a bid by a deadline, and whether you place that bid and how much you place is a function of what you learn about this space and how you would develop it in that interim. So these are all wells, these like black dots here, and I just drew it like an island, but you know it could be anywhere. It could be like a lease in Eagleford or something. So like, here's a bunch of wells, and maybe there was a report somebody wrote about these wells. Well, that's interesting to you. You're going to want to study that report to see how these wells did and whether there's still like hydrocarbons around that area. And some of that data might be structured, which could help you to do some instant evaluation rather than having to pour exhaustively through the unstructured stuff. And that could pertain to individual wells. You might also want to look at like offsets that are nearby your lease and what reports came from them, and some of that stuff might be structured. You might also look at like public data and semi-public data. And when I say semi-public, I mean like there's a paywall like SEG or AAPG. You buy the rights to stuff that's been published about that area. And some amount of that might also be structured. But just because it's structured doesn't mean it's easy for you to look at. Like just a really quick interlude here. Here's like some structured data in somebody's report, but like you can't just like port this into Excel using traditional tools very easily. You have to like highlight and copy and paste. That's really hard to do. You know, do quickly and exhaustively when you have a huge amount of data. And you do have a huge amount of data. Like the reality is you have way more data than you have time to look through. And whenever we talk to oil and gas companies, this is like a big deal, you know? They have like about enough time to look through maybe 1/4 of the total DUT files that are relevant to an important decision they have to make on a lease or an acquisition. That's not good. And so they're only looking at 1/4 of the total amount of stuff. They're only getting 1/4 of the total insight. So they're making underinformed decisions, and that's costing them a lot of money. There's no contrapositive, so you can't say like, well, for the exact same place at the exact same time, we did it 2 different ways. And we realized that if we had had all, you know, 4 out of 4 here, like the entire gamut completely researched, how much better it would have been. But it doesn't take a genius to realize that like you're definitely missing out on a lot of important stuff here and losing some money as a result when you're only looking at 1/4 of it. Another like, you know, sub issue here is if you want to attract great people to this industry and to this job, so that they can actually apply their skills that are like not rote look for data skills, but like useful, exciting, you know, subject matter expertise skills. You're going to want this part to be done for them so they can just like have the data at their fingertips and apply their expertise to helping to inform the decision rather than like looking for all the data, you know? So that's one issue. But another big issue in here is that what happens when like I'm running out of my time to look through this because I'm coming up on the deadline here, and some amount of the data that I know is, you know, should be in there, but I couldn't find it, is like still missing from what I looked up. So what do I do in that situation? Typically, I pay a consultant to come in and like give me that data again. So now I'm spending extra money, but I'm also like just adding to the problem because maybe we then like want to go and explore an offset to this whole area. And if we do that, we're going to have to go through all this data again. And now I've just added to it with more stuff that's maybe redundant or maybe isn't, you know? So this problem is getting worse and worse. Those are 2 like use cases in a little bit more depth. Let me talk about Delfin now. So Delfin is, I describe the business model. We're like really, really fast at setting up tools. We're like software that sets up tools for specific use cases in oil and gas. We come in and we use design thinking to learn about the use case. And then we use our software and our oil and gas expertise to get that use case set up. So how does it work? Well, you can like type to it or you can talk to it. You press a button, you ask a question, and you get an answer. And it's instantly access your firm's most relevant knowledge. It's the best collection of relevant answers that exists in the data that you gave the tool access to. So it looks like this. There's a web app, there's mobile apps, or mobile website. You can access it on your phone or through a computer. And then what is it used for? Well, there's really like three use cases now, three big use cases. One is the sort of Q&A exhaustive enterprise search that gives you back snippets from unstructured files, and it gives you back the metadata too. So like you can see like when that file was published, and you can access the full file if you want, and you can see who wrote it, and where in the organization they sit, and how to contact them, and that sort of thing. But if you ask a question, you're not getting back the full file all at once. You're getting back the relevant part of that file and the relevant part of another file. So this is an example. She says, hey, what's the flow rate that a Series F flow meter can accurately read? There's some unstructured downtime that's costing the company a lot of money. And it's because this flow meter is acting up, and it seems to be reporting a leak. They haven't found a leak, but what the heck is wrong with the flow meter? So she asks this question, and it gives her something from the operating manual. It can measure flow rates up to 50 gallons per minute with really small error margins. Hey, that's great. But it also gives her this other information here that came from somebody's report that got written a long time ago, and that person retired. And what they discovered was that this flow meter, its accuracy is a function of the length of straight pipe upstream of the meter. And what you notice is this flow meter has been installed downstream of a bend. And for that reason, it's acting up. So now she has this like insight, like, oh, no wonder this is acting up. It's on a bend. And then she asks the next question to our tool, which is called SIA. So she asks SIA, hey, how much straight pipe does it need? And then it's going to give her an exhaustive answer to that question instantly. So she's drastically reducing the amount of downtime that her organization is facing. That's a really big deal. That's very important. I gave this example earlier. This is the second thing our tool does. Here is some data that's like structured, but it's scattered across unstructured data. But what if you just like want all of that? Typically what you have to do is some like tough OCR process that's not very accurate. Well, we can take care of that for you. So with all of the unstructured textual files that you give us, it just like gives you back, here's the tables, whatever you wanted from in there, it's now in a table that you can mess with. It could be Excel, it could be like a SQL database, whatever. But then check this out. Like not only is it going to give you this back, but you notice in the actual table here, there are some missing places, some missing data. Well, maybe that data or something that like is very a good fit to go in there exists in another one of your files. Okay, and this is a specific example agnostic, right? So what our tool will do is it'll like look at and find these blanks and then fill them in for you with data that exists in some other file. And then you can click on this to see where it came from. And maybe there were multiple values that were contenders for that spot. So what are the runner-up values? Maybe they were like conflicting values, and so it didn't really know which one to give you. You can sort that out using the tool instantly. That's a really big deal also. So you're getting like comprehensive data here, and it's now tabulated. This is the scattered data that was like scattered across stuff, and now it's organized for you in one place so you can get your work done and actually use your expertise and have some fun at work. The third and final thing the tool does is like maybe you don't know what data to assign to each use case. So you've got like a bunch of use cases for us, and you want the tool to help you with those use cases, but you don't know like which specific files apply to which use case. Like we just have this big unstructured, folder that's filled with a bunch of different files. So you can use our tool to assign tags. You can tell us what tags you care about, and the tool will go through all of those files and assign tags to them. So it'll say like, this has something to do with drilling, this has something to do with legal, this has something to do with geology, but hey, that legal one also has something to do with geology. So it's not like it only gets one tag. There can be multiple tags assigned to each document. And then you kind of know like what data pertains to what. And that's valuable to you in its own right, but it also then helps you to figure out how to then corral the right data for a specific use case of the tool that's doing this unstructured to structured data analysis for you, as well as a tool that's just like finding answers for you within the unstructured data. So that's the three things the tool does. Just one more time really quick. First thing it does is it answers your questions with snippets of relevant information from exhaustively across all the files you have given it access to. Second thing it does is it automatically fills in your spreadsheets instantly and accurately with the data that's scattered across those same unstructured textual files. And third and finally, but often used first, it's just perhaps less value add overall, is hey, it'll just like assign tags to your unstructured files, so you know what files have to do with what subject. So there you have it. We're Delfin, and I hope that this has been an interesting thing to listen to, and that you'll want to check us out more. So please do reach out if so. Thank you.